everyone. Welcome back to SAT Math Question of the Day. Here's our question of the day. Please give it a shot. Try it, then pause the video. No, pause the video, try it, and come back. Here we are. Consider the above system of equations. Which of the following is true? There's one solution, EF, and E times F is positive, negative. There are infinitely many solutions or no solutions. Boy, a problem like this, my intuition tells me there's more than one way to do it. And if you're super smart, and if you see the pattern, you could probably do it in a second. And, wow. Well, it makes sense to simplify. I forgot to annotate. Makes sense to simplify this, doesn't it? To make them all on one side. 11e minus 9f plus 1 is equal to 5f minus 15e. You're going to mess it's very easy to mess that up.
Well, how did you get to 15e?
5 times negative 3.
Oh.
Wait, you didn't see that?
You multiply out.
Yeah, no, that's a big mistake.
You multiply out.
Yeah.
So you notice Joel made made an algebra step there.
Yes. Now, we're noticing pattern. F and E are on the same side on this equation. So let's put F and E on the same side on our equation. We're subtracting a 5f. So it's negative 14f. So we'll just sort of cross those off there. Now we're adding a 15e. So that's 26e is equal to negative 1. Well, they certainly look like they have only one solution, don't they? Because those are seriously different equations.
Right. Yeah, it has serious. Notice the 4 and the 2 in the first equation. The second equation that they gave you, the ratio of the coefficients is 2 to 4, and in the first equation after simplification, the ratio is negative.
Right.
So the ratios of the two coefficients are different. So there's either, and so general principles tell us that means that there's a unique solution.
Right. In other words, the equations don't have the same slope. The coefficients in front of those are not multiples of each other. In other words, it's not 4f plus 8e. Right? If it was 4f plus 8e, then you would have a problem, right?
Yeah.
So we can rule out that. Now, let's see. Is there a clever way to figure out, without actually having solved for f and e, is there a clever way to see whether f times e is positive or negative? You could. Well, so now the question is, does it take more time to come up with a super clever way of doing it, or just do it? Maybe we should just, I don't know, maybe it's a graphical approach. 2y is equal to 3 minus 4x, and negative 14y is equal to negative 26x minus 1. I'm changing f and a just to confuse everyone, just because it's more intuitive to do y's. I'm making the f be y and the x be e. No, Seth doesn't like this. It can be potentially confusing. Negative 14f minus 26e. So if you're going to graph this thing, let's just see where the intersection point is, and that'll tell us whether e times f is positive, right?
Let's tell us basically solving it.
Yeah, so basically you have a 3, and the slope is negative 2. So in other words, this line goes like this, and this line here is a negative 1, and its slope is about negative 28 over negative 14. So its slope is positive 2. And we can't tell whether x and y are positive. They look like they're both positive. Wait, we can't tell because this may have actually been lower. Oh, that was a waste of time. How would you do it, Seth? Would you just solve for E and F?
I think at this point I'd solve it.
Really?
Using elimination and then back substitution.
Yeah,
And
wow.
you'll
So
see
this is
what
a
they are.
long problem. So this requires you to actually solve two equations, two unknowns.
But maybe after do elimination to get one of E and F, and then knowing that you know whether it's positive or negative, and then look at one of the equations to
Right,
get the other one, and they'll tell you if the other one is positive or negative without actually solving for the other one.
right. Yeah,
I would solve for one of them and then back substitute into the simplest looking equation, and then read off from the single variable equation whether the solution is positive or negative, and then check. Then you could tell the sign of the product, because you know the sign of one you know exactly
yeah,
one variable, and you could
yeah.
observe the sign of the other variable, and so you know the signs of both, and so you can
Right.
know the sign of the product.
So I have F. I have F as 2/5, which is consistent with that little graph, right? X was fairly small. So F is 2/5. So 2 times 2/5 plus 4E is equal to 3. So this is 4/5, right?
E has to be. Sorry. Keep going. Keep going.
Yeah, this has to be 4/5, but 4/5 is about 1. So 1 plus 4E is
Four
3.
fifths is less than three,
Yeah, well, it's about 1. Yeah, so
so
E is
clearly,
positive.
yeah, E has to be
So it
positive.
looks like the answer is positive. And when I
Yeah,
did my little graph, that actually would look like it was positive. But
yeah.
that's right. They have a graphing calculator on this test.
Ah,
Yeah, so you could have graphed this using a graphing calculator. I'm pretty sure, yes, on the digital SAT, which is what this is taken from, you could use a graphing calculator, and you graph these
mm,
things the way I wrote them, and then you would see the answer immediately. That's probably faster. I think that's faster.
yeah.
But you have to be.
Well,
Did you
so
notice?
the graphic calculator basically let you plug in, let you type in two linear equations, and it will show you the two graphs, and it will show you if they show you, and when it shows you the two graphs, it will also show you
The
what their
intersection.
intersection
Of
is,
course,
and
of
then
course
you
it
can
will. Yeah.
tell.
Okay, well, okay. So I need to do some investigation. I need to go to Redbook or Blue Book, whatever the SAT people application is for doing the digital SAT. Start it up because I have an account, and start a practice test, and go to the graphing calculator, which I believe is Desmos. And generally, Desmos does allow you to graph 2, 3, 4, 5, 6 things on the same plot. So I have to do my homework to see whether that is true, and I will do that later today. And we're not going to waste our time now doing it because they have to log into Blue Book and do all sorts of stuff. But I think we can assume that the graphing calculator on the SAT will allow you to graph two linear equations. In that case, it's probably that may have been faster, but you would have to be very careful in moving everything over to the same side. Oh no, solving for y. I think it's possible, and I think it's also possible in Desmos. You can type 2y plus 4x is equal to 3,
Mm,
and
mm.
negative 14y plus 26e is equal to negative 1, and Desmos will know what to do. That's so that there's two different. Yeah, so we have at least two different approaches to doing this problem: the algebraic way or the graphing way.
Hmm.
I just have this intuition. There's some super smart way of doing this, but I don't know. I mean, given these equations, it's really hard to tell. Plus, it's very close. It's right on the border. This x is only 2/5. So dealing with
Yeah,
small numbers here, as we saw when we grafted roughly.
yeah.
Yeah, yeah. Should we just as an experiment? Should we go to decimals and just see if you're going to do 2y plus 4x is equal to 3, and negative 14y plus 26x is equal to negative 1. Okay, we got it. Okay, let's go to Desmos and see what happens. So the answer is A. Clear all drawings. Get out of here. Desmos. Graphing calculator. Here we are. Graphing calculator. Here we are. Okay, here we go. 2y plus 4x equals 3. Ooh, it graphed that nicely, didn't it? Negative 14y plus 26x is equal to negative 1. Done. And just right there, right? X is 2/5.
Oh, wow. It's very close.
Yeah. Yeah. My little graphy thing actually looked pretty good.
Wow.
Yeah.
So you just type it in and you graph, yeah.
So
well, if you were, I don't know, if you were doing this on the SAT, it might be wiser, instead of simplifying the first equation, to just type it in. Because then you just you use more typing, but there are fewer steps of algebra, so fewer opportunities to make a mistake. But there's more typing,
you could have typed
and
that
so
in
there's
directly.
more possibility of making a typing mistake.
So let's.
But once you've typed it in, it's easier to check that the expression you typed in is identical to the expression on the question.
Right. Let's try it. Let's use E and F also. Let's actually use E and F in there.
Yeah.
Yeah, let's give it a shot. Ready? Here we go. 11E minus 9F plus 1 is equal to 5 times F minus 3E. Oops. It didn't like that. Didn't like that. Did it? It didn't like that, did it?
Could you click on the exclamation point? Does it give an X?
I'll try it again. 11E. I think it probably, when you give it an implicit equation, it may only like X and Y. Okay. Sorry. Yeah. So we have to change it to X and Y. Fine. So, okay. Well, this is something to know. This is a good thing to tell people. So we do 11X. Does it matter which one we do as X and... No, it doesn't, does it? Does it matter which one we make X and Y?
You just have to be consistent.
Yeah, okay, fine. It doesn't matter. Okay. So it's 9y plus 1 equals 5. Now, F was the y. So this could potentially be confusing. So I typed it in wrong. Because that equation...
Uh-oh, it's wrong.
Yeah.
Wrong graph.
11x minus 9y plus 1 is equal to 5y minus 3x. What is going on? I don't know. Now 2y plus 4x is equal to 3. So that one's right. That's the right one. But what's going on up here? Oh, because
you put in E. You said 3E instead of 3.
Yeah. 3x. Yeah. There we go. Okay. So
okay, there you go.
There we go. Okay. Ooh, that's nasty. Now you ought to be really careful if you do this.
I think it when you typed E, it didn't give you an error because it interpreted E as the the base of the natural logarithms. In other words,
right? Yeah.
The E in the exponential function.
E is
2.78.
Yeah. E is like pi. E is a natural number in math, so to interpret E as actually a number, E is equal to 2.71 something. Wow. They did that on purpose. They probably did.
Oh, because they expected people to use a calculator?
Yeah, possible.
Oh.
You don't know, right?
Yeah.
We don't know, yeah. So anyway, I mean to do the research and find out whether you got full-blown Desmos on the SAT. I'm pretty sure you do. I'll look today. Okay, so anyway, let's see how they do it. Okay. Ooh, it said show calculator. Wait. Oh, here, look, show calculator. Yeah, here it is.
Oh,
Yeah,
there it
so
is.
let's see if the calculator will do it. 2y plus, well, yeah, so that answers it, right?
Yeah,
Yeah, yeah. And then we'll just do y equals x. It doesn't matter, right? Wow, look at that. Y equals x is almost the same line as the.
yeah.
Oh, it is. It is y equals x because the two are very close to each other. You got the 14. You got the 14 and the 26. Right. Okay. So there we go. That answers the question. That they.
No, wait. Why?
I just put something in so
Okay,
that
okay.
it was just a test. It was just. Okay. Great. Now I wonder whether
So
they are going to say to use the calculator. That would be nice. Wait. So where's the answer? Oh, here we go. Oh, I wish they would offer the option to use the calculator.
mm,
I mean, to graph it. 4 steps. Ooh, a lot of algebra. Oh my God, they actually got
so
it.
they solve it.
Ouch.
Yuck.
Yeah,
That's
ouch.
dumb.
Yeah. First, use the distributive property, so that's good. We had to get that equation. We did the first step. Then you eliminate. Okay. Then you eliminate, and then we knew that E was about 2/5. Nobody cares that it's 20 over 54. Just make it 2/5. What difference does it make? It's probably not going to matter. They're not going to give it. Just approximate it as 2/5. And then they do even worse. Then they do 10 over 27. 10 over 27. Okay, whatever. 1/3.
Wait a minute. Wait.
They simplify 20 over 54.
Wait, when you solved it, you got which one was 2/5?
X. Wasn't it?
Was that an approximate? That had an approximation or exact?
No, it was an approximation.
Oh, I didn't. You didn't make it clear that it was an approximation.
Oh, you're right. I'm sorry. You're right. You're right. Yeah.
No.
Man, we could go back to the video. I think I probably said, "Oh, it's like 2/5." Yeah, but you're right. But there's no need to carry 10 over 27. It's too much algebra. Look out.
But again, you eliminate, you'll get you'll get say E right away.
Yeah.
And then by plugging E, then by back substituting, you could tell right away what the sign of the other number is.
Right. Yeah.
By simply simplifying the constant, right?
Right.
And then you could tell, then the equation will have the form coefficient times f equals constant. And you could tell right away what the sign of f is from the coefficient and the constant.
Yeah, absolutely. And
without doing the arithmetic.
And it took a chance approximating, but it's not likely they're going to put something in that's so close that the error is going to matter. But also notice
it's still dangerous.
It is dangerous. But the graphing way to go.
I wish you told me because I thought I actually solved it.
No, I didn't.
Yeah.
Notice also there is exactly one solution down at the bottom here. Come on. And we knew, you want to tell that ahead of time.
You have to be very careful because if you have two equations, right, and the ratios of the coefficients, in simplified form. The ratio of the coefficients in one is very close, but not equal to the ratio of the coefficients of the other. Then you're going to have unique solvability. So if you make an approximation that then makes the two ratios equal, you misled yourself.
Wait, did I do that?
No, you didn't. You were lucky.
No, but how close were those?
Yeah. Frankly, it wasn't too bad. Because
where are the equations?
Because the ratio on one equation was positive, and the ratio in the other equation is negative.
Right.
It
Yeah.
indicates us that the two lines had slopes in opposite with opposite signs,
Yeah.
and so the slopes are not very close together. They'd only be very close together if they were both close to zero
Mm.
or both close to infinity. Either if they're both very large,
Right.
uh, or the ratios were very large, or their ratios were close to zero,
Mm.
then you have to be careful.
Oh, you're
But
right.
here they were. You could actually see, one of the slopes was -2.
Right. Yeah, no, I see that. Yeah, they are close. Yeah, that was dangerous. When I
Yeah,
did this, the intersection point was too dangerously close here. So you're
yeah,
right. It probably wasn't a great idea to change 20 over 54 to 2/5. That probably was not a good idea. Yeah, you're right. You're right. You're right. You're right. But it looks like the graphical approach here is the fastest, most efficient way to do it. Just go to the calculator, graph the two. You have to know to change, like you just change x and y, or up here you have to be consistent and change the x and the y, and then you just graph it.
yeah, yeah. No, it's disappointing that Khan uh, uh, does not does not demonstrate the use of the calculator.
Or then also, or in more general, doesn't demonstrate the fact that demonstrate that there's more than one way to do each problem. It's a
Yeah,
real
yeah,
disservice. It's a real disservice. So that's
yeah.
hopefully,
Well, yeah, yeah,
we're
one of the
trying.
problems, the shortcomings of the way math is taught, is that they do not emphasize that there's more than one way to do problems.
You are right.
They convey the impression that there's only one way to do
Yeah.
a problem.
Yeah, absolutely right. Absolutely correct. Absolutely correct. Yes, and the only ever it's really up to you as the user of your homework. If you're interested, if you want to see the different, see the problem from different viewpoints.
So, any teachers who are listening to this, please teach your kids that there are many ways to solve the same math problem.
And wait, but people who probably prepare for the SAT, or let's say they take a course, or let's say they take an instructional course. Most you would think that most instructors would say, okay, there's the way to do it at school, and then there's the way to do it on the test. Because the way to do it on the test, if you could see a pattern or you could see a faster way to do it on the test, you do it that way when you take the SAT. So in that way,
well, we've observed that certain other tests, the Hunter High School entrance exam, solving the problems in time depends on observing coincidences,
right, yeah,
among the numbers
but
and
that's
among
true.
the algebra.
And that's to a certain extent true of the SAT, also, and probably the ACT. Yeah.
Mm.
Okay. Anyways, so I guess we're done. So thanks for bearing with us here. I hope you got something out of this. Big lesson. Think how to do the problem more than one way, and the graphical approach is always keep the graphical approach in your head. Okay, I guess to finally introduce ourselves, I'm Joel. I have a PhD in mechanical engineering from Columbia University. My brother Seth here is my brother, his PhD in math from MIT. We take slightly different approaches given our educational background and our personalities. And he's a retired professor at SUNY Albany in computer science. And we are here to hopefully offer different approaches. That's what we do, is we try to say, yeah, there are different ways to do the problem, and sometimes on the SAT it merely makes sense to do it a way you wouldn't do it at school. And in terms of studying for the Math SAT, Khan Academy is pretty good. They offer two online courses, one for the digital SAT, one for the non-digital SAT, although the non-digital SAT is saying goodbye in the United States. So, and they give you 600 or 700 questions that are sanctioned by the College Board. It's a great way to practice because all the stuff on the new SAT post 2016 really all comes from schoolwork, not a whole lot of IQ as opposed to the older tests. So it's a good idea to learn the material that's on the test, which is basically learn material that's in school, and practice, and then go to the College Board and take their practice test. Okay, and I will go to Blue Book for the digital SAT, which is their application, and confirm that Desmos will come up, and Desmos will allow you to graph 2 graphs at the same time. Okay, anything else, Seth?
No.
No, I think we're done for today. Oh, tomorrow's Thursday already? Short week. So
Tomorrow.
Wow. Tomorrow's Thursday already. So that's
what that means.
That's Throwback Thursday. When we go back to over 20 years and we look at an SAT question from before 2016, when you had to do more IQ stuff, and there were questions there you never would have seen in school. So, okay, I guess that's it for today. Great. Okay, everyone, take care. Bye-bye. And I have to move this little thing up a little to stop the recording.